So in this video we're going to be looking at the derivation of the third formula in trigonometry, or also known as the third trig identity, which is the cosine rule, which we have written here. And as usual in the videos, I have a little green box there that's really worth while taking down and learning off by heart. So you might want to pause the video now and write it down. I'll explain it. So what I mean by draw the extended unit circle, what I mean by that is a scenario like this. This is not a unit circle here. This is a radius 2. So we can clearly see that it is not a unit circle, but it is an extended unit circle is what I like to call it. And this point here in the previous video so it was cos A, or in the previous one it was 1 cos A, but here it is now 2 cos A, 2 sine A. Over here the radius is 3, so this point is 3 cos A, 3 sine A, and here the radius is B, so this point is B cos A, B sine A. So the first step was to draw your extended unit circle of radius B. Point 2 was to draw a point in quadrant 2, so Q2 meaning quadrant 2, and label it B cos A, B sine A, so we're labeling the angle as A. You're going to draw in a point C0. Now C0 should be outside the circle, and I'll show you what I mean by that point C0 and where it should be. Looking here, we can clearly see that this point is 6, 0. Okay? It is 6 along the x-axis and a 0 on the y-axis, and I've come along a distance c here, so this point is C0. So there is where you're going to want to draw it, but make sure it's just outside the unit circle. Then what we're going to use is the distance formula between the point C0 and B cos A, B sine A. So the diagram, what the diagram looks like is this. We have our extended unit circle with radius B. We have our angle A, so we know these 2 points up here, B cos A, B sine A, are the coordinates of this single point. We know this length was C long, it is C long, so we can call this point C0. And it's important to note that opposite angle A is side A. So I know how long this is, it is A long. And what we're going to use then is the distance formula between this point here and this point here. So important to write down the distance formula. Our 2 points, label them x1, y1, x2, y2. Fill them into the formula, and we know, remember, the distance between them was a, which we showed on the diagram. Next step would be to square both sides. So now we have an a squared over here, and by squaring this right hand side, this whole thing, we're getting rid of the square root. 0 minus b sine A is just minus b sine A. And now we're going to go into the process of multiplying out those two brackets. So I've color coded this quite a lot. So this yellow section I've just split and repeated, or split the bracket and multiplied it by itself. So c by the entire bracket and minus b cos A by the entire bracket. On the right hand side here, minus b by minus b is b squared, sine A by sine A is sine squared A, and I've already explained in a previous video as to why the squared is there, so worth going back and having a look at that. C by C, C squared, C by minus B, C cos A. We like to put that in alphabetical order, so it's going to be minus B, C. Similar here, minus B by C would be minus B, C cos A. Minus by minus, it's plus. B by B, B squared. Cos by cos, cos squared. I've highlighted this red section here because this is kind of like treating it as a minus 7x, and look, I would have a minus 7x as well. This is as if it were the x section here, and we would get 2 times that, or minus 2 times 7x, which which would be minus 14x. Okay, so I have a minus x here and minus x here, they get brought together and I get 2 times it. On the blue side here now, is there anything I could factorize out of this blue section over here? I could factorize out b squared from both of them. And what have we already proved? We've already proved in Formula 1 that we know this is equal to 1 in the first trig derivation. That is equal to 1. From page 13 of the log tables. And you're done. QED. Really nice formula and derivation, and it really does come up quite a bit in the Leaving Cert.